Hi guys, so another question for you, and again a question picked up from the constrained motion lecture. So here we have what's new, what's different over here. We have two movable pulleys. So we had two earlier, but we have two different strings where the action is going on. There is this string, then there is this string where two masses are there, another this string is there, the masses are there. So there are different strings where the action is going on. Your previous question, you had pretty much the same string going all around, and they were attached to the pulleys, and the masses were directly attached to the pulleys. So it was one string where the main action was going. Here it is two. Now I can do again in terms of masses and going to analyze, but it is up to you to do that way now. I'm going to straight away take the mass and do the question now, because the point is not analyzing the final answer. So that I've already discussed that you should be doing. Here I have to make a different point, so we'll straight away go on to that. But before that, I am very much interested in knowing what you feel, whether pulley B is going to go down or pulley A is going to go down. Between the two, what is going to go down, or are they going to remain at their own spot A and B? Are they going to remain at their own spot, and only this mass 3 is going to go down and 1 is going to go up? What do you think is happening? So analyze that, and before you pause and analyze, I'll give you a hint. I'll give you another situation which will act as a hint for analyzing this. So that's the situation, somewhat similar to this. So what I'm trying to make a point over here is the total weight on this pulley is 1 kg plus 3 kg, which is 4 kg, and the other side is also 4 kg. So the masses here, mass this side and mass this side is balanced. So what do you think? Is this pulley going to go down or not? Is this going to go down or go up or not? And if not, if it is going to remain there, then is it only these two masses which is going to go? So I'm asking you to analyze that. That analysis should help you to analyze this. So I hope you got an answer over here. The thing is, it was kind of a bluff. 1 and 3 is 4 and this is 4, but still the string is going to go one way. I'll tell you which way. Had this been a 2 kg and 2 kg, had the situation been like this, that's 4 and this is 2, this is 2, then I agree that nothing was moving. 2 and 2 will balance each other in this. So this will neither go up nor this will go up. Both will balance each other. So the total mass this side becomes 4 kg. The tension over here becomes a 4 kg force tension or 40 Newton tension. Because the tension over here, if this is not going there, this is not going there, if nothing is moving, the tension over here will be 20 Newton, 20 Newton, 20, 20 will give you a 40 Newton tension. A 40 Newton tension is going to balance it perfectly, so nothing is going to move in this direction. Now what's the difference between this and this? This mass is 4, this mass is also 4, but still one side is lighter in a way than the other side. Why? Because if this starts moving, if this was not 2 and 2, it is 1 and 3, then do you think the tension will be same? No, the tension becomes less. The tension releases. So if the tension has become less, this is a lesser tension over here. So this 4 kg mass will be having will be greater than the tension, opposing tension, and hence your 4g weight is going to effectively counter T and make the body go downwards because the T has become lesser. Yeah, so since the body had started moving, the tension had released. So this was your T by 2, if that is your T by 2. So if the tension has released, then this tension is less than the initial when it was 2 and 2. It is less than that. So since the tension is less, the body is going to go down this way. So it's a mathematical certainty which I'm getting from a feeling of physics, that it must be a mathematical certainty that when I am disbalancing it, I'm putting a 2 plus something and a 2 minus something over here. Then this side is becoming heavier as well as this side is becoming smaller. So it is going down in a big rush, and when something goes down in a big rush, the tension decreases big time. So even if the mass has increased, the tension has decreased because the rush has increased. So if somebody wants to solve this mathematical certainty, is most welcome to solve. In fact, okay, I'll do it very fast for you. So say this is m plus x and this is m minus x, and we have to compare the tension with the tension had it been m and m. If it was m and m, both side was balanced, the tension would have been equal to mg. Now I'm saying that if you disbalance, if you add a certain amount to this side and subtract the same amount on the other side, it is disbalanced. This is bound to be less tension. That's a feeling of physics. You don't have to actually calculate. You can do the whole question in the way which is not the way it is not happening, and still you'll get the right answers by setting your signs. You might get your signs opposite, but then you can figure out which way was the right answer. But here, just to let you know that it is a mathematical certainty, let me just do a quick calculation over here. The acceleration would have been, if I see the force mg, m plus x g is the force here this side, and m plus x g is the force this side. So on these two bodies totally, the force is m plus x g minus m minus x g. That's the net force, as I had explained earlier, that if you open up the situation and make it a force this side, the first question what we had done, divided by the total mass this force is pulling, force here, force there. So net force is this minus this, and the mass is m plus x plus m minus x. So what we get on top is m and m gets cancelled. You have 2xg on top and 2m at the bottom. So it is xg by m. Means if there was no disbalance and x was 0, then your acceleration was 0. If x was 0, your acceleration was 0. Now, if a is that much, how much is the tension? So we can take any one mass and write the equation. So taking this mass, the equation is m plus x g minus t is equal to m plus x a. I hope it is in the frame. So taking m plus x a this side, what we get is t is equal to m plus x common g minus a. Now how much is g minus a? A was xg by m. So what we get is, it is equal to m plus x g common 1 minus x by m. Which means if I take the LCM over here as m minus x. So what we get is m minus x into m plus x. So that gives me a nice m square minus x square g divided by m. Now this quantity m square minus x square divided by m times g, this tension has to be less than mg. Why? Because this value will be less than m square minus x square being always positive, x square, whatever x is, will always be positive. So this numerator is always less than m square. So m square by m would have been m. So less than m square by m is less than m. So the quantity comes less than mg. Hence, the tension is bound to, this tension T dash is bound to reduce, and hence if the tension has reduced, then the tension in this string, which is 2T dash, has reduced from earlier. So if that tension is reduced, the body is going to go down. So coming back to this question and a similar analysis, Let me draw the tensions first. This 2 kg mass is through a movable pulley, so other side is also the whatever tension this gives, other side is the same tension, so T and T 2T, so this tension becomes 2T. So had the things been stable, was this not moving anywhere, had it been 2 kg 2 kg, then everything would have been balanced, because 2 kg 2 kg would have given 20 Newton tension, means 40 Newton tension over here, 40 over there means 20 and 20, which balances 20 over here, so everything would have been stable. But again the same thing, this side is moving. If this side is moving, tensions are released, so this T has become less. If this T has become less, then what is expected, what was in the previous scenario when it was 2 and 2, if this T has become less, then this pulley is going to go down and this mass is going to go down. So we have figured out that this body is going down, so we'll name it some acceleration variable to it. This is going down, this pulley is actually going down. Acceleration of pulley A is downwards. So if this is downwards, this pulley is directly attached to that pulley through a fixed pulley, so this pulley is going up. So with the same acceleration, so if I call it acceleration simply as A, then I'll call it also as A. So instead of introducing extra variables, so it is A and A. So once we have figured out what is the acceleration of this pulley, we can figure out what is the acceleration of this. If this goes by A, this goes down with 2A, that's the constraint. So when it goes down by A, there is a loose string of A and A around it, so this has to go down by 2A because this side is fixed. Now here these two bodies are independent. This body is going down with respect to that pulley and this body is going up with respect to this pulley, and the whole pulley is going up. So this body is definitely going up, it is going up with respect to the pulley, and the pulley itself is going up, so this is definitely going up. This body is going down with respect to the pulley, but the pulley itself is going up, so this might be going up, but most probably it is going down. 3 and 1, we'll see on the calculation. So say the body 3 is going down with A dash with respect to pulley, and hence this is going up with A dash with respect to pulley. So what will be the actual accelerations of 3 and 1? Actual acceleration of 1 would be A plus A dash. A dash with respect to the pulley plus the pulley itself is moving up with A. You may write a vector equation to get this. You may write it as acceleration of body, what do you call this body as, say body 1 kg body 1. So that's body 1. The one with 1 kg is body 1, one with 3 kg is body 3, one with 2 kg is body 2, suppose. So A1 with respect to ground will be equal to A1 with respect to pulley plus pulley with respect to ground. That's your vector equation. So 1 with respect to pulley was A dash upwards, and pulley with respect to ground was A upwards. So what you get is A dash plus A upwards. Similarly, if you do this, then if I take upwards as positive, then it would be A minus A dash. The body goes up because the pulley has gone up with A. So the body goes up with the pulley by A, but the body itself has gone down with A dash with respect to the pulley, so it comes down with A dash. So ultimately it has gone up with A and come down with A dash, so it has gone up with A minus A dash. You could have also said that it has gone down with A dash minus A. So your wish, whichever way you think you will take. A dash seems to be much larger than A, so it will actually be going down with A dash minus A. So you can use that equation or this equation. So you should know what direction you are taking. So A dash minus A downwards is as good as A minus A dash upwards. So any which you can take and write the equations. So now let us write the equations. We have done enough analysis over here. Let us write the equations. So the pulleys are massless. Next we'll take pulleys with some mass in the next example. So here the pulleys are massless. So if I call this as T, 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 then this will be 2T, 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 again T over here, T over here, T over here, T over here. So first, writing the equation for this, that's the simplest. It looks like the simplest. So it is going down with 2a. So what we have written, what we have to write is, since it is going down, the net downward force, which is 2g down, mass into gravity, 2g down, minus the tension upwards, is the net force, is equal to mass into acceleration. 2 was the mass, and how much is the acceleration? 2a is the acceleration. How did we get that? We assumed the pulley is coming down with a, and through the constraint we got this 2a. So I'm not writing different variables like a2, a1, a3. I'm not writing. I've done all the constraints over here, so I've minimized my variables. The variables what has remained on the board are tension, acceleration, and a dash. These variables I have taken. So I hope to make 3 equations. I've got 3 bodies. I'll be able to make 3 equations for the 3 bodies. So this is your equation number 1. Next, for this body, it's going up ultimately with a plus a dash acceleration. So the body has got a tension upwards minus the weight, which is 1g downwards. So 1g downwards is equal to the mass, which is 1, into acceleration, which is a plus a dash. That's your equation number 2. Similarly, equation number 3. So would you like to write down or up? Once you write, you'll understand that you could have written any which way. So if you think this is positive, a dash minus a downwards it is going, then the weight 3g is overcoming t. So 3g minus t is equal to mass into acceleration downwards, because we have taken downward force as positive, so mass into acceleration downwards. Mind you, if you have taken upward as positive, we would have written t minus 3g. T minus 3g is equal to 3 times this, a minus a dash, 3 times a minus a dash. So the equation mathematically would have remained the same. So even if you don't know which way it is going, up or down, the mathematical certainty will remain same. We have used this instead of that. We could have used that. In that case, it should have been written as t minus 3g instead of 3g minus t. So let's solve this. We have 3 equations and 3 unknowns, t, a, and a dash. Let's get done with a dash. Let us remove a dash using these 2 equations. Let us just do away with a dash and have an equation between t and a only from here, and then we have an equation between t and a from there. From there we'll eliminate t and get your a. So let me clear the board first. So from equation 2 and equation 3, I can divide with 3. So we'll have a plus a dash, and we have the other one as a dash minus a. We can subtract the 2 equations. So this equation number 3 I'll rewrite as g minus t by 3 is equal to a dash minus a. So that's your modified equation number 3. Now your equation number 2 and equation number 3 you can just simply add, but when you add you'll get your a cancelled and a dash remains. So I'll subtract. So when I subtract, my a dash is going to go away. So what we have on the right hand side is a minus of minus a, which is 2a. This t minus of minus t by 3, which is plus t by 3, gives me 4t by 3. And minus 1 minus g gives me minus 2g. So that is what I get from 2 and 3. So again, taking the LCM and removing the denominators, I get 4t minus 6g is equal to 6a, or 2t minus 3g is equal to 3a. And from the above, I had 2g minus, so I'll just double and write, because I have 2t, I'll write 2t over here. I'll just double this and write over here. So I have 4g minus 2t is equal to 8a. So I've doubled equation number 1. That's your equation number 1. And that is the equation from what you got from 2 plus 3, equation 2 and 3 combined. So from the 2 I can just add the 2 equations and the things will eliminate, and what I'll get is from these 2 equations I will get g is equal to 4g and 3g gives me a g is equal to 11a. So I get A is equal to G by 11. So that's a fraction of G. Thankfully, none of the answers in this situation can come more than G, because nothing can fall with the acceleration greater than the free fall, even if one of the mass was 0. So I get A is equal to G by 11. Quite satisfying that it is actually a fraction. And what was that A? A was the movement of the pulley. It was none of these mass. So what is the acceleration of this 2G thing? It must be going down. That was your 2A. So 2A must be equal to 2G by 11. What about this? It is going up with A plus A dash. So we have not found out A dash yet. So to get A dash, we will eliminate T from here, from equation 2 and 3, and write a new equation for that. 2 and 3, from 2 and 3 I'll eliminate and write a relation between A and A dash. So when I add it, why am I using this? I can simply eliminate T. I have not found out T anywhere. I don't want to find out T. So I'll just add it. So what do I get? 3G minus 1G is 2G. T and T gets cancelled. I'm just adding. So we have a 3A dash plus A dash. We have a 4A dash over here. And then we have a and minus 3A. So minus 2A over there. So I get my A dash, 2A dash in fact, is equal to G plus A. 2A dash is equal to G plus A. So your A dash is equal to A was equal to G by 11. So we have G by 11 plus G, which is 12G by 11, and divided by 2. So this gives me a 6G by 11. So A dash is equal to 6G by 11, which is again a fraction, but it is yet the other accelerations are yet to be added. So let's see. So what's the acceleration of 3G? So A dash is rightly much more than A. So it is 6G by 11 minus A, which is G by 11. I guess I had taken G by 11 over there. Yeah, I have taken G by 11. So we have 6G by 11 minus G by 11, which will be equal to 5G by 11. And this is going up with a 6G by 11 plus G by 11. So that will give you 7G by 11. So that's the acceleration of body 1 kg, body 3 kg is 5G by 11, and body 2 kg is 2G by 11. So that's your situation. So main thing over here, the analysis, what I was wanting you to do is which one will get slack, and the other important thing over here is this concept. We are taking acceleration of block 3 and block 1 with respect to pulley. That means as if the pulley was not moving. If the pulley is not moving, then 3 is going down with A dash, then this guy is coming up with A dash. So it is going down with A dash, that was marked here, and this guy is coming up with A dash with respect to the pulley. But if the pulley itself is going up with A, then even though it has gone down with A dash with respect to the pulley has gone up with A, so it has ultimately moved down with A dash minus A. And this had gone up with A dash with respect to the pulley, and the pulley itself has gone up with A, so totally it has moved A plus A dash up. So here we have written in the minimum variables possible for A and taking into consideration all constraints. Hence the solution was not big at all. 3 equations for the 3 masses, and then 1 or 2 steps for eliminating, making a 3 equation and 3 variable case to a 2 equation 2 variable case, and then solving the 2 simultaneous equations of within 2 variables, which you have been doing from class 9 onwards, class 8 onwards, whatever. So that's your solution. So I'll show one more case which is having a slightly different concept from all these, but very easy one, and then we'll go on to a totally different kind of question.